Let's practice some of these noble gas configurations. Make sure that you have a periodic table available and feel free to pause the video so that you can try the problems yourself before watching me work them out. So for a noble gas configuration, first thing you do is reference, even though we're doing a shorthand configuration, we're still going to need our off-ball diagram. So let's draw one. And we start by listing all of our S's all the way down to 7. Try to make your lines as straight as possible. And then we start with our P's, starting with 2. And we will never go down to the 7th level, but you might eventually in some class, so you might as well know how to write it. Then you start with the D's, starting with number 3. And then you go to F, and that's the last orbital. And 7F. Then you need to draw your arrows to show you the order. Make sure you actually put an arrowhead on them, otherwise they don't show you direction. If you get your line from 2P to 3S, that one is usually the one that sets my angles, so it helps me make sure I'm going through the rest correctly. And then 7F. So let's look at rubidium. If we look at the periodic table, we can see rubidium has 37 electrons. So I'll make a note, 37 electrons. And for noble gas configuration, we're always going to find the noble gas immediately preceding that. So we will put krypton in brackets. And this just means the first 36 electrons, because krypton has 36, look just like krypton. And we use the noble gases because they have the perfect electron configurations. They have the ones everybody else is trying to get through chemical reactions. So now we have to decide where that one extra electron is, because krypton has 36 and rubidium has 37. If you look at your periodic table, you can see that rubidium is in the 5th period. So we will start at 5s. And since we only have one, we'll say 5s1. And that shows you rubidium's 1 valence electron. Let's look at silver. Silver has 47. And the noble gas before it is krypton again. So that tells you where 36 electrons are. I'll make a little note here. You don't have to, but that way you can tell. Silver is in the 5th period as well, so we're going to start at 5s. It's 5s2, so now that's 38 electrons. We need to go to our off-ball diagram. From 5s here, we're going to go to 4d right here. D orbital can hold 10, but we don't have 10 more electrons. We have 38, we have 9 more electrons. So 4d9. Let's talk valence electrons for just a minute. The valence electrons are the one in the highest energy level. 5 is the highest energy level. So silver has 2 valence electrons. This is technically in the 4th energy level, even though it's more energy. We only count the ones right here. Let's look at gold. Gold has 79. The noble gas preceding it is xenon. And xenon has 54 electrons. Gold is in the 6th period, so we're going to start at 6s. 6s2, that gives us 56. From 6s, go to 4f. So 4f, 14. And sometimes it's easy to keep a calculator next to you and just kind of keep a tally. So now we have 70 electrons. That means we have 9 more. From 4f, we go to 5d. We have 5d9. This one's still 2 valence electrons. So all those transition metals are going to have 2 valence electrons. Aluminum has 13 electrons, so we don't really need the noble gas shorthand to save us time, but we can do it for any of them. Neon is the noble gas before it. Neon has 10 electrons, so aluminum's first 10 electrons look like neon. Aluminum is in the 3rd period, so we're going to start at 3s2. That gives us 12 electrons, and then 3p1, following our off-law diagram. Copper has 29 electrons. The noble gas before copper is argon. Argon has 18 electrons. Copper is in the 4th period, so we're going to start with 4s. 4s2, that gives us 20 electrons. And then from 4s, go here to 3d. So still 2 valence electrons. We forgot to add them up here for aluminum. Aluminum has 2 plus 1 gives us 3 valence electrons. Iodine has 53 electrons. The noble gas before iodine is krypton. I know it's closest to xenon, but you can't use a noble gas that has more electrons. So the first 36 electrons look like krypton. Iodine is in the 5th period, so we're going to start with 5s. 5s2, so that gives us 38. From 5s2 here, we're going to go to 4d. It's going to be 4d10. That gives us 48 electrons. From 4d10, we go to 5p. We go to 5p, and we need 5 more electrons. So we have krypton, 3s2, 4d10, 5p5. And iodine has 7 valence electrons. 5 here, plus 2. Now take a minute and I want you to look at silver, gold, and copper. Do you see how all 3 of them end with D9, 4D9, 4D9, 5D9, 3D9? Look at your periodic table. Copper, silver, and gold are all in the same group. They're directly on top of each other. This is one of the reasons we can use the periodic table to check or even create our electron configurations. And we will talk about that next.